All right, we're back. We're on page 199 of math analysis. We are kind of wrapping up parametric equations now, I guess. So these are mostly review. So let's see if we can do them. So, I mean, hopefully we can. It says to do them with some serious speed. So we'll see what that means. It never seems to go all that fast, but you never know. All right, look at this. It's a circle. There's no additional directions. So I'm going to say -3, 1. I'm just going to go 4 cosine of t. And 4 sine of t. There's a million other things we can do, as I hope you're aware by now. An ellipse, x, y, 5, -2, plus 4, no additional direction. You always go cosine sine. So this is all just practice. I kind of debated not even making this video, but then I thought, I don't know, if it helps even one student, I guess I should do it. I don't really go in for that. In case you're unaware of that, I do want things to be worth the time. 8 cosine. So this is an ellipse. It doesn't even matter. Like, I wasn't even thinking about it. I was like, well, I see a plus. I'm just going to go for it. Wherever it goes, it goes. Hyperbola. Hyperbolas do matter. So you do have to think like a little bit. So y is going first. So x, y, -1, 8. So that's a place where you could make a mistake because h, well, I mean, I don't know that you would make the mistake here because, you know, like, why would you be like x, obviously -1 goes with it. But in this form, right, when somebody's like, what's the center? It's hk, so -1, 8. So parametrics almost have an advantage in that sense, almost. Plus 7, plus 6, and then this has to be secant because y has to go first, so this will be 10. Or, so I mean, for the other ones I didn't really do this, but because these are a little different, we could, you can't just swap secant and tan, but what you can swap is cosecant for secant, and you can swap cotan for tangent. So that's what I'm gonna do. Cosecant. And then obviously I recommend that you try to graph these. You could graph them on your Inspire, you could graph them on GeoGebra, a lot of options, 2 options. What are you? 2 squareds and a minus, it's definitely a hyperbola. So I need to make sure that I just get the secant and the tangent in the right places. So this, 0, -2, you don't need the 0, but for me it helps to just have the form correct, I think. So this will be √20, and then x goes first, so let's put secant there, and then plus √12 tan, or we could do the cosecant cotan thing. So instead of writing it again, I'm just going to switch colors and say or cosecant t cotan t. You know, I kind of like how vibrant the blue looks, especially on my iPad. The colors don't really translate 1-to-1, which is unfortunate for you. All right, so here I have to complete the square before I can really do this. It's going to be a circle though, because it's 2 squareds and a plus. So I know it's going to be a circle. Let's complete the square. Well, I mean, how much work should we show? Probably more than that. X squared minus 6x plus y squared minus 2y. Equals 10 plus 9 plus 9 plus 1 plus 1 square root of 20. X minus 3 squared plus y minus 1 squared equals 20. So the radius is the square root of 20. That's why I said square root of 20. And then it's just a circle. X, y, center is 3, 1. Plus √20 cosine plus √20 sine. So there were no additional directions, so I went with cosine sine every time I could, because I know what happens then. It's going to start on the rightmost point. It's going to go counterclockwise. I kind of know like when it's going to hit each point. I think that's really good to walk in knowing. Just makes things easier to solve. So eliminate the parameter, find the eccentricity. Blah. All right. Saying blah about the eccentricity. So can we, I mean, you could basically do this in one shot, right? So I'm going to subtract 2, get x minus 2, divide by 3. x minus 2 over 3. I'm going to square that. That's going to give me x minus 2 squared over 9. And then here, I'm going to add 3. That's y plus 3 divided by 5. So y plus 3 over 5, square it and add it. So it's y plus 3 squared over 25. And then sine squared plus cosine squared is 1. So this is a circle. Therefore, the eccentricity, this is not a circle, this is an ellipse. What am I talking about? An ellipse, c squared equals a squared minus b squared. So c squared is 25 minus 9. So then c squared is 16, so c is 4. So the eccentricity is going to be c over a, 4 over 5. I'm going to highlight that. Okay, I think that's good. So if I were going to check these, which I'm not going to, I would probably graph this. I think I'd do it on the calculator. Graph this on the calculator, switch, graph this on the calculator, see if they overlap. If they overlap, good. Then from this, you can use analyze graph, conic, and get the eccentricity and just check it. So that's what I would do if I were going to check, but I'm not going to. So here we're going to get x plus 4 squared over 64. So I added 4 divided by 8, squared it, plus quantity y minus 8 squared over 25. I subtracted 8 divided by 5, squared it, added them together to get 1. So this is an ellipse again. So c squared is again a squared minus b squared. I mean, you like can mess that up, but if you mess it up, you're going to get like c squared equals a negative, which doesn't make any sense. So then you're like, oh, I got to switch those again. So c squared is 64 minus 25. So 64 minus 20 is 44, minus 5 is 39. So c is radical 39, which makes our eccentricity c over a radical 39 over the bigger one, so 8. And again, just check them the same way. I'm not going to check them. So also after you check them, let me know if I got any wrong, which I may. All right, let's see. So this time I need to use secant squared of t minus tan squared of t equals 1. Whenever you're not sure, just write it down. Like, it's not a big deal. So I need to get secant squared first. So this has to come first. So I'm going to end up with, now I used t right here. I could have used 2t, I could have used 10t. It doesn't make a difference. It's secant squared of something minus tan squared of the same thing. So since these are the same thing, we're good. If they were different, we would not be good, and I don't know what we'd do. Also, check out the auto shape there. Also, I don't know what I just did. I don't know how I made that happen. First, I had like an auto-shaped circle. Nah, it's gone. I don't know, the magic's gone. I don't even know if it happened. I'm gonna go back and watch the video. Anyway, we're gonna get y squared over 25, right? Divide by 5, square it, and then minus x squared over 9 equals 1. This is definitely a hyperbola, so c squared equals a squared plus b squared. So c squared is 34. So the eccentricity is going to be radical 34 over, for hyperbola, a always comes first, so it's just 5. And then that should be bigger than 1, which it definitely is. And we can check it. But I'm not going to. There's so many of these. All right, let's go. I don't even know if we're going fast. I don't think we are. All right, I got to be cognizant. Secant's got to go first. So it's going to be x minus 9 squared over 9 minus y plus 8 squared over 25 equals 1. C squared is a squared plus b squared. 9 plus 25, 34. So the eccentricity is going to be radical 34 over a always goes first. Okay. Rolling. Let's keep going here. Circle. How do I know it's a circle? Sine, cosine, well, cosine, sine, and then same radius for both of them. So this is definitely a circle. So let's do x minus 4 squared. So I could do x minus 4 squared over 12 squared, and then plus y plus 1 squared over 12 squared equals 1. It's not really how you write circles, though. So I'm going to write plus y plus 1 squared equals 144. Since this is a circle, we know the eccentricity is 0. That's good. Got that one out of the way. Cosecant, cotant. Like, who uses that, you know? But it's cosecant squared minus cotan squared. Every year I have like one student who does it, and like does it naturally. They don't just do it to be like, you know, the person who's, oh, I'm doing a funny thing. They just like do it. I think that's so weird. Y plus 3 squared over 64. This is just us doing problems together, you know. Same thing, c squared is a squared plus b squared, so radical 73. Oh, no. It's 73, not radical 73. C is radical 73. So then our eccentricity is radical 73 divided by 3, because a always comes first for these. So got to know that stuff. These are like, there's like no application, so they're like kind of boring. Oh, look, cosecant and secant again. Oh, I was about to try to erase this because I just saw it. I was like, get out of there. I hate when it makes little dots. All right, so cosecant has to go first. I'll be impressed if I get all these right. Because, you know, going kind of fast, kind of talking about stuff. That's how it goes. Suffer the consequences. Okay, so our eccentricity. These are very similar eccentricities for a lot of these. It's basically the same problem over and over. A always goes first for a hyperbola. For an ellipse, A is always bigger. And finally, an ellipse. Now, there's kind of an issue here because the this is not the same for both of them, right? We got this and this. So I'm just going to rewrite this one. It actually won't make a difference. I'm going to use the fact that sine is odd, right? So the sine of negative t is the negative of the sine of t. So this is minus 5 times negative sine of t, which is just plus 5 sine of t. Okay, so this, what are you? This is another circle. So I'm going to get x minus 4 squared over 25 plus, y minus 4 squared over 25 equals the radius squared. So we get this. So it's a circle, so the eccentricity is 0, which is like a lame-ish way to stop, but it's not going to stop me from stopping. Okay, so that's practice page. Just, I don't know, we didn't really do anything. We just kind of like eliminated parameters, introduced parameters. May have gotten them wrong. I hope not, but you can check them, and I hope that you do. And I'll be back in the next video to do some more. So I will see you there.